Yeah, Mansi, one is comparable with whom?
1, 1.
One, I am precisely asking, one is comparable with whom? One is comparable with one. One is comparable with two. Yes or no?
So your voice is
Mansi,
cutting.
I will repeat.
It's not clear.
Mansi, you will let me know whether you have understood this.
So your voice is cutting. It's not clear.
Now, yeah, Mansi.
Yes, sir.
Yeah. So what I'm saying now, when two elements are comparable, did you understood this?
What?
Hello, Mansi. Now, hope you are able to hear me.
Sir, I lost my connection. So what was the question? I'm sorry.
I said, where it is here. Huh. Did you understood this? When we say two elements are comparable in a poset, yeah, Mansi, just quickly answer me.
Yes, sir.
Is it clear? If it is clear with respect to this, I asked a question. One is comparable with whom?
1.
Only one.
2, 1. Yes,
Again,
sir.
I will repeat. Coming back here, when we say two elements A and B, they are comparable with each other. When either A is related to B or B is related to A. If either A is related to B or B is related to A, we say A and B they are comparable with each other. If A is not related to B or B is if A is not related to B as well as B is also not related to A, we say they are incomparable. Okay. So I will ask another way. What are the elements that are incomparable with element 6? 6 is incomparable with whom?
4,
Okay. What else?
5,
Yes. Very good. 3 is incomparable with whom?
5,
Yes.
4,
Yes.
2.
Yes.
Yes.
Perfect. Very good. You can mute now. So this is what we discussed just now. That's it. Now, what exactly we will discuss, this is done. Now, the next concept that we need to understand that is called as total order. What is meaning of total order? If S comma partial order relation is a poset, S comma some partial order relation is given, if this is a poset and every two elements of S are comparable, then we say S means that poset, that given set S is called as totally ordered set, and that partial order relation is said to be total order partial relation. I will repeat again. If you take any two elements from this set and if or any two elements are comparable with each other, then we say the given poset is totally ordered poset, and the given partial order relation is total partial order relation. So with respect to this, Mansi, again unmute.
Yes, sir.
Is it clear, first of all, what is meaning of when we say this set S is totally ordered set? Is it clear?
Sir, can you repeat? Sorry, I didn't understand it.
You just read out loudly this highlighted version.
If comma
Partial
is
order relation.
if S comma partial order relation is poset and every two elements of S are comparable, S is called totally ordered set.
Oh, okay. When any two elements of S are comparable, then we say given S is a total order set, totally ordered set. Now coming back here, what is your opinion? What about X? Is it totally ordered set?
Yes.
Again, read out loudly. What is totally when we say S is totally ordered?
If S comma partially ordered
Hmm.
is uh, is a poset and every two elements of S are comparable.
Every two
And
elements are comparable. Every two elements. Every two elements means what? You take any two elements, any possible two elements. They are comparable. Then we say it is totally ordered. So
so
in this,
X is not
ah, when
totally
you say
ordered
X is
set.
not totally ordered, you need to give some instance, some counter example. So what is that counter example?
Because 4 comma 5 is not related to each
Yeah.
other.
4 is, it is not 4 comma 5 is not related. 4 is not related to 5.
Comparable.
5 is not related to 4. Therefore, X is not partially ordered relation. This is the way you should conclude. Okay, you can mute. Okay. Uh, so total order we just now understood. What we will discuss now, like relation and function, partial orders have some convenient graphical representation. It is just a convenient graphical representation where you need to draw the Hasse diagram. So how to draw the Hasse diagram? First, okay, before this, what I will do, we'll have some example is in our, this is what we are having this example with us. Yes. Okay. So you need to draw the digraph. What is meaning of digraph? We already seen how we represent this relation R in terms of graph. So you need to express in terms of some nodes. How many nodes are there? 1, 2, 3, 4, 5, 6. 6 vertices are there. So let me have some vertices. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. This is your diagram. I have not yet completed it. So 1 comma 1. So you are just having this in terms of graph 4 comma 2. That means this is the edge. No, 4 comma 2 means it is related like this. Next is 6 comma 2. This is related. Next is 2 comma 2. That is self loop. 3 comma 3. 4 comma 4. 5 comma 5. 6 comma 6. 6 comma 3. 2 comma 1. 3, 1, 4, 1, 5, 1, and 6, 1. Okay. So this is your diagram. In terms of graphical representation, we have shown your partial order relation. Okay. This is the way you are showing your partial order relation. Okay. Now, can we have a simplified version of this diagram to represent, since this given relation R is partial order relation. It is a partial order relation. That means what? It holds three properties to be satisfied, that is reflexive, antisymmetry, and transitivity. Okay. These three properties are holding. So can we simplify this diagram so that we are able to interpret the graph with respect to these three properties? So in Hasse diagram, what we do normally, we go level wise. We go level wise. So let me just, now whatever you have drawn, it is something like this. If you express in terms of matrix form also, 1, 2, 3, 4, 5, 6. Okay, just for simplicity. So 1 is related to 1, 4 is related to 2, 6 is related to 2, 3 is related to 3, 4 is related to 4, 5 is related to 5, 6 is related to 6, 6 is related to 3, 2 is related to 1, 3 is related to 1, 4 is related to 1, 5 is related to 1, 6 is related to 1, 2 is related to 1, 2. Yes, I think this is done. This is what you are having as a relation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So this is your exactly the relation that you are having in matrix form. That's it. Okay. So what exactly you are doing? You need to identify. Basically, this is your A now. And just right here, A related to B. A R B. So your A is this and B is this. Okay. All right. So what you need to check? You need to check from B perspective. What is that B? What is that B which is not related with someone? Means you can see here 1 is a B element. So if I look at 1, 1 is related to only 1. It is not related to anyone. So that is your first level to grow for. That is your first level to grow from. I will just do one thing. Eliminate this, don't say. So we are starting with level 0. So in level 0, we take all such B's at this level, such that no one are related to that except itself. No one, no, no, it is something like that. Wait a minute. Is subset. Okay, this is So what I'm saying now here, that one is related to one, and one is not related to any other element. So that is your seed level. Rest of the things also you need to check. Is there anyone who is just related with itself? No. So at level 0 or level 1, you will have that element that is 1. So you will eliminate the self loop. First of all, please try to understand. By default, we understand or we interpret without self loop. This node is there. In that, this diagram we will term it as a Hasse diagram later on. In Hasse diagram, every node is related to itself. So we just eliminate showing loop. Okay. So one. Now next thing is what? One is related to whom? One is related to two, three, four, five, six. Okay. What is our objective now to go ahead is
Sir,
this. Yes.
can we take a short break for 5 minutes?
Pardon?
Can we take a short break for 5 minutes?
Let me conclude and then we can take a 5 minute break. Let me just conclude this, what I'm talking.
Okay, thank you.
So what I'm talking right now here is that we need to go level wise. So one is related. What are those elements that are related to one? What are those elements that are related to one directly? Directly means we can have many more elements that are related to one. Like in this case, we can see 2 is related to 1, 3 is related to 1, 4 is related to 1, 5 is related to 1, 6 is related to 1. So what we need to understand out of this, okay, so for us, for this one, what are the next level elements? I want to go for level 1. So what are the possible elements I can have? 2, 3, 4, 5, 6. I'm just writing here. 2, 3, 4, 5, 6. These are the possible elements that may come at level 1. So out of this, we need to take only those elements such that now within this we need to check, is anyone is related to with its someone. So you can check for 2, 4 is related to 2, 6 is related to 2. So definitely 6 is related to 2, 4 is related to 2. So we will eliminate this from this, because someone is related with some element. So we will eliminate this. Is 3 is related to 2? No. Is 5 is related to 3? No. Is 2 is related to 3? No. Is 2 is related to 5? No. Incomparable element. We want incomparable elements. So now these are the right candidates to come for the level 2, that is 2, 3, and 5. Okay. And then we are having this relation like this in the graph. Now, what are the elements that are remaining out of this? 2, 3, 4, 1, 2, 3, 5 is over. Now what is remaining? 1, 2, 3, 5 is over. 2 and 6 is remaining. 2 is covered. 4 and 6 is remaining. So out of these 2, which one will come at level 2? We need to check whether they are comparable. Is 4 is related to 6? Is 4 is related to 6? No. Is 6 is related to 4? No. So they are incomparable. So therefore they will come at level 2. And now 4 is related to whom? 4 is related to 2. That's it. It is not related to this. 6 is related to whom? 6 is related to 2. 6 is related to 3. And that's it. This is your Hasse diagram. We are done with this. This is your Hasse diagram. We'll take a break of maybe 3 to 4 minutes and we will resume back. So let us resume. What we are discussing at present is the Hasse diagram. Uh, Let me recap again how we constructed this Hasse diagram. Basically, your Hasse diagram is having elements. Element A comma B belongs to R. So basically, we need to, what exactly we show here in Hasse diagram, we go from bottom side to upside, showing like this. A is related to B. While interpreting this Hasse diagram, we come top down fashion. This is related to whom, 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 and somewhere we terminate. Okay, so though we interpret this, but we go constructing from bottom to top, like we will take all those elements at level 0 such that this is not related to any other node except itself. So we'll take all those nodes in level 0. Then we will eliminate all these nodes that are listed from the set X that you are having. From that, we will eliminate all the nodes that are listed in level 0, and the same process we will redo for the level 1, same process we will do for level 2 and level 3, like that. So, to get the more confidence, I will give one more problem statement to all of you, which you need to work out right now. Let us take one example. You have been given set S. You have been given set S, that is A comma B comma C. Okay, and you have been given the poset, that is the poset is given to you is what? Poset is this, that is P of S. Now what is meaning of P of S? Power set of S, comma, the relation, that is partial order relation, that is subset. So construct the Hasse diagram for this. This is the exercise I am giving to you now. Now to construct this, you need to first come out with this power set of S. Once you come out with this power set of S, come out with this relation R that is applied on this. Once you get this, you are ready to start with this. So, I'm just writing here S is equal to A comma B comma C. So what is power set of S? That I already described in earlier classrooms. So can anybody tell me what will be the elements in this power set of S? Yeah, Sarah Khan, unmute yourself. Hello, Sarah Khan. Sharvari Gaikwad, unmute yourself. Am I audible? Viraj Gunjal, unmute.
Yes, sir.
Yeah. I don't know what about Sharvari. Sharvari, are you present? They are marking absent, those who are not present. So, Viraj, tell me the elements belonging to this power set.
Power set. So can you show this table?
Which table?
Oh,
See, this set
it's
S is
related
given to
things.
you, which is A comma B comma C. Power set of S contains what? What is power set of S?
Our set of S will be having.
Be louder little bit.
One sec, sir, I'll restart the mic.
Pardon?
Hello, sir. Sorry, sir. My mic was not working.
Yeah, tell me now what is power set of S?
Uh, Sir, power set is the subset of. It
Correct.
is the set of all the subsets.
Very good,
So,
very good. So tell me now, what are the elements in this?
it will be A comma B.
A comma B? Is it like this?
Yeah, set A comma B.
Is it
Then
like this?
hello.
Hello, is it like this?
Yeah.
Power set
No,
is what?
set, sir. Set symbol, not bracket.
Set, yes. So let us go step by step.
So
First
first
is
single
null
and
set.
null set. Then
Okay. Then
then the single element set A.
एक minute. Yeah, set containing A, set
Set
containing B,
containing B, set containing C. Then set containing AB, BC, AC, BC,
very good,
and ABC. Set containing ABC.
very good. Now this is power set, right?
Yes, sir.
What is relation R is given to you? A R B. What is that relation is given? Where R is subset. Are you getting?
Yes,
Hello.
yes.
So can you give me one example of this ARB? Which element is related to which other element? Under this relation R, that is subset. This is your poset. Your poset is what here? Poset is power set of S and the relation is subset. This is your poset. Okay. So let us have that relation R to be written here. How many elements are here? 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Okay. 5, 6, 7, 8. Okay. So this is null set. Null set. So this is set containing A, set containing B, set containing C, set containing A comma B, set containing B comma C, set containing A comma C, set containing A comma B comma C. That's it. Set containing A, set containing B, set containing C, set containing A comma B, set containing B comma C, set containing A comma C, set containing A comma B comma C. That's it. Okay. So now, who was there when we were talking? Who was there? Sarah Khan, I think. Yeah, Sarah Khan.
Yes, sir.
Tell me now, which element is related to whom? Come on. Now these are the elements of our set. Which element are related with some other element under this relation R? Are you getting or not?
Sir, and what is the relation?
This is already I told no that subset.
Okay, okay. So A is a subset. A and null. A
So
and
let
null.
us go line by line.
Okay. Null and null.
This is
It
related to
is,
null.
yes, it is related to null set.
This is related to this.
Yes. A is related to null set.
Let us
No.
go step by step. Null set is
No.
subset of this.
Yes.
Null set is subset of this.
Yes.
Null set is subset of this.
Yes.
Yeah, tell me now.
It is a subset of all of them.
Now tell here.
Uh
I am here right now.
no, no. Yes. No. No. Yes. No. Yes. Yes. No, it is not. It is not. It is. It is not. It is. It is. No. Yes. No. 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 Yes. No. Yes. 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 No. 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 Yes. No. No. Yes. No. 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 Yes. No. Yes. No. 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 Yes. Yes. So for this all no, only the last one, yes.
Yeah, very good. So that's it. This
Yes,
is
sir.
the relation R, and now you need to construct the Hasse diagram. You means all students. You need to construct the Hasse diagram. So what I discussed here earlier, that we need to start from bottom to we need to build from bottom to top. So at level 0, we will take only those elements which are related to itself, which are related to itself only. They are not related to some other elements. So let us check what are those elements which are related to itself. They are not related further with anyone. So basically, you need to check. This is your A. Wait. Basically, this is your A, and this is your B. So you need to check all those B which are not related with any other element. So you can check here null set. They are not related to any other element. Or null set is related to this. But what are those elements? How to view this? Basically, null set is related to null set. Null set is related to this. 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 Null set is subset of every other set. Okay. Now, what is meaning of this? Exact opposite. Who null set is superset of who? It is no one. It is itself only. You just need to check. Is there any other set which are subset of null set? Is there any other set which are subset of null set? Only null set is subset of itself. No other sets are subset of itself. So this is your level. Likewise, do you have any element which is having only relation with itself? Do you have or not? You confirm with yourself. So Sarah Khan, let us go together in sync. Tell me now at level 0, which element you will consider at level 0?
Sir, I did not understand. I'm sorry.
Okay. I will again repeat what I'm talking here right now. Let me take the earlier example for your case. This is the given relation R, okay, on some set containing 1, 2, 3, 4, 5, 6. We don't bother about that relation. This is straight away relation is given to us. That's it. What is our objective? Our objective is to construct the Hasse diagram. Previously, we have drawn that Hasse diagram. How we have drawn that Hasse diagram? We need to start with level 0. So we for level 0 we do have how many options? 1, 2, 3, 4, 5, 6. These are the elements. Now we'll take only those elements which are incomparable. Incomparable means they are not comparable with rest of the elements.
Sir, means they are not related.
8 minutes. A or B. In Hasse diagram, how it is used something like this. It is some. A related to B. This is the interpretation in Hasse diagram. Okay. So our objective is to find out this B such that no other elements are related to this except itself.
Okay.
So what are those elements in this? Our objective at level 0 is this. We need to identify that element B such that no other element are related to this element except itself.
Okay.
So what are those elements out of this? Which are
6.
acting like B.
6.
If you take 6, there are elements like 6 is related to whom? What is the relationship we are having?
Only it is related to 6.
Divisible relation. So
What is it?
divisible 6, 1. 6 is related to 1, no?
Yes, sorry.
Our objective is to identify that
5.
5.
5. But it is related to 1 again. Yeah.
Please try to understand. Our objective is this. If you say 5, then 5 is not related to someone.
Okay.
We want some atomic level, means this is not related to some other element except itself. So what is that element?
1.
Yeah. So it is the only element 1 which is related to itself. 1 is related to itself. It is not related to any other element. So therefore, you will take 1 here. Okay. So after eliminating 1, what are the remaining now? 2, 3, 4, 5, 6.
Hmm.
Now out of these 2, 3, 4, 5, 6, what are the next element? That you will consider in level 1. Same concept.
Okay.
Now here, obviously, level 0 we have. So within this, we are talking. 1 is not in picture now, within this.
Okay, so we remove 1.
Yeah, we have removed 1 already.
Okay. Then 2. 2 is only related to 2.
Yeah. 3 is related to some other
3.
element. What about 4?
4 is also related.
1 minute. We need to check
4.
this way.
Yeah.
3.
So 4 is related to 4.
See. We need to check this way.
Okay.
2 is related to 2.
2. Yeah.
3 is related to 3.
3.
4 is related to 2 and 4.
Okay.
So there are more elements.
Okay.
5 is related to 5 only.
Okay.
So there are now 2, 3 and 5. They will come now in level 2.
Sir, but okay, I understood.
2 is related to 1, 3 is related to 1, the earlier one. Okay, that's it. So this we have removed. Now what is remaining? 4 and 6. So we need to establish level 2. So
sir, in level 1, 2, 3 and 5 will come, no?
Yeah, I have drawn this now. Here. This
Yes.
is level 1. This is level 0. Now we want level 2. Out of this, what will come in level 2?
5 and 5 and 6.
Pardon?
5 and 6.
No question of 5 and 6. We are having now 4 and 6. 5 is already gone in level 1.
Oh, sorry. Then 4 and 6.
Okay.
4 is only related to
1
4.
minute. Before this, let me conclude. How you have concluded which one will come and which one will not come. Let me conclude this. Yeah. So here, try to understand what we have done. 6 is comparable. Is there any element which is comparable with 6? Let us answer this question, Sarah. Quickly.
Sorry, for the whole thing, right?
Yeah, now this is entire thing is with you.
Yeah.
Is 6 is comparable with anyone?
Yeah. With 1, 2, 3, 4 and 1, 2, 3 and 6.
Okay. 5 is comparable with anyone?
Yeah, with 1 and 5.
Okay. Now when I say comparable, no, it means I am relating this way. 6 comma 1, 6 comma something is there or not? That way.
Yeah. 6 comma 1 is there, no?
So for 6, comparable element is 1. 6 comma 1 is there. Is only 1 is there for out of this?
No. 1 is there, 2 is there, 3 and there and 6 is there.
Right. For 5?
For 5, 1 and 5.
For 4?
1, 2, 4.
For 3?
1 and 2. 1 and 3.
For 2?
1 and 2.
And for 1?
1 itself.
So for this element, you do not have any other element which is comparable with itself except itself. Are you getting?
Yes, sir.
That element we have taken here as level 0.
Yes, sir.
So now this element is gone. So what is remaining now? Rest of the options are now 2, 3, 4, 5, 6. This is the level 2 we need to consider. So at level 1, again the process is same.
Yeah.
What are the elements that are comparable with 6?
With 6.
Huh?
2, 3 and 6.
So there are, apart from 6, there are any other elements. So we will eliminate this.
Yes.
What are the comparable elements for 5?
Only 5.
So it is the right candidate for level 1. What are the elements for level, element 4? Comparable elements.
2 and 4.
So apart from 4, there are some other elements. So therefore, it is out of question.
Yes.
What about this? Comparable
Only,
element?
yes, it is. Because only 3.
What about this?
Only 2.
So we'll take this at level 1. And of course, we do have this in level 2 because they are related to 1. 1 is there in level 0. So this is the relation. Now what is remaining? 4 and 6.
Yes.
And 6. So process is same again for level 2. 6 is comparable with whom?
6 is comparable with 6.
So this is the candidate that is in level 2. 4 is comparable with whom?
4.
So this is also a right candidate for
Level
level
2.
2. So this is your level 2. Now 4 is related to whom? 4 is related with 2.
4.
6 is related to whom? 6 is related to 2. That's
Oh.
it. This is the Hasse diagram.
Okay, okay. Yes, I
Now, how to
understand.
interpret this diagram? Every node are related to itself. So 1, 1, 3, 3, 2, 2, 5, 5, 6, 6, 4, 4. Now how to interpret ahead? 4 is related to 2. 4, 2, 2, 1,
1.
4, 1, 6,
Okay.
3, 6, 1, 5, 1. These are all elements belonging to this relation R. So from Hasse diagram, you can construct this relation R also. So now going back to the
6, 2 भी है ना?
okay, any doubt up till now
6,
here?
2 भी होगा ना?
Pardon?
6, 2.
Yes, 6, 2 is also there. You are right. 6, 2 is also there.
So 6 comma, why 6 comma 5 is not there?
Why 6 comma 5 is not there? Because 6 is not related to 5. 6 is not divisible by 5. 6 is divisible by 2.
Okay, yes.
Okay. So this is your Hasse diagram. Any
Yes.
questions on this? If it is done, if there are no questions, you need to work on now on this and come out with the Hasse diagram.
So we did this only now.
Oh, sorry. I'm talking about this now.
Yes.
So come out with the Hasse diagram for this given partial order relation.
Yes, sir. So do you want me to tell step by step or all together?
Okay, let us go step by step.
Yes.
Level 0. Now,
Sir, for
for
level
level 0,
ABC.
एक minute. Okay. I am asking question now. Now, Sarah Khan, you go on mute. Let me take some other student. Sharvari Gaikwad, mute yourself. Unmute yourself. Sharvari Gaikwad, are
Yes,
you
sir.
there? Yeah, please tell me now. A comma B comma C, this set containing A comma B comma C, this is comparable with whom?
Sir.
Okay, what is our relation now that we are discussing? Subset.
Yes.
What is our relation is now? Subset.
So only with itself.
So, subset means what? Let me make you aware what exactly we are talking. This is A and this is B. So, A related with B. What is that relation is? Subset. A is subset of B. This is the relation. A is subset of B. Okay. So, coming here, now tell me, this is comparable. What are the comparable elements for this?
It's
Pardon?
A, B, C.
No. Please try to understand what I'm saying right now. When I say A is related to B, it
Yes.
means what? How I interpret this A or B. So B is here and A is here. Okay. So when I say what are the comparable elements for A, it is A and B.
Okay.
Are you getting?
Yes.
I'm
Yes.
talking about going in this direction. So when I ask you about this, what are the comparable elements? Means what I am asking now, A comma B comma C. This is the set containing A comma B comma C. What are those elements that are to whom A comma B comma C is related? Are there any elements? That is what I'm asking.
No, sir.
No.
There are no. Yes.
So this is the right candidate for considering at level 0. What about this? A comma C, they are related to whom? Under subset. The relation is given here now.
Mm,
What are the
A and
comparable
C.
elements?
A
Hmm?
and A and C and also AC.
Pardon? Be louder.
Uh, A AC and ABC.
Okay. So that means apart from itself, it is also related to A comma B comma C. So therefore, it is not the right candidate at level 0. What about this?
It is also not, sir, because
Why?
it is also related to ABC and itself.
More than apart from itself, it is also related to some other.
Yes.
Okay. What about this?
It is also not.
What about this?
No.
What about this?
No.
What about this?
No, sir.
What about this?
Mm,
is it is a superset of itself. No, wait.
So therefore, only one candidate is there, that is A comma B comma C, which is at level 0.
Yes.
Which is at level 0. Wait a minute. So now eliminating that element, again we need to repeat the same process for level 1. Now out of this, yeah, Sharvari,
AC,
this is related to whom?
it is
This,
related to itself and ABC.
now I'm talking about only in this pool I'm saying.
Okay. Only AC.
Okay, so this is the right candidate. What about this?
It is also related to itself.
What about this?
Yes.
What about this?
No.
What about this?
No.
What about this?
No. No.
Pardon?
No.
What about this?
No.
So at level 1, you will get A comma B. I'm not able to draw properly. Please cope up with my handwriting. And now you need to check, since please do remember, all the elements at the level 2, they are by default related to level 1. They are by default related to level 1. There is no question that only this element will be at level 2 and it will not be there. They are by default related with level 1. That's it. So now, what is remaining now? What are the elements remaining? These are the elements that are still remaining. That is into our consideration. So Sharvari, going ahead for the next level. Tell me now, this is related to whom?
This is related to AB and ABC.
Out of this, I'm saying.
Oh, out of this,
Comparable element.
two only C.
Pardon?
C only C. Itself.
C is subset of itself.
Yes.
Okay. What about this?
It is also a subset of itself.
What about this?
It is also a subset of itself.
What about this?
It is. It is. It is a subset of itself.
Pardon?
Wait.
Be louder. I'm not able to hear. Yeah. What happened, Sharvari? Hello.
Wait.
Pardon?
Yes, sir.
What yes? C is related to any other element apart from this.
No, sir.
So
Sorry.
therefore, we have
No.
included this as an atomic element. B is related to some other element in this pool.
No.
Set A is a subset of some other in this pool.
No. Only to itself.
Null is subset of any other except this in this pool.
Yes, sir. It is a subset
So
of.
therefore, we have not considered this. It is having more than one. Apart from itself, it is related to some other element. So therefore, these are the candidates which will go in level 2. And now we need to check, set whatever this set A is subset of what? So Sharvari, tell me.
Set
In
A.
level 2, we need to establish the relationship. This is subset of this.
Yes.
Is it subset of this?
No.
Is it subset of this?
Yes.
Is it
B
subset of this?
B A B
Is it
A
subset
B
of this?
C.
Is it subset of this?
No. B C.
For this?
Yes.
And
And
for
A
this?
C.
Yes. Now, what is remaining? Only
Null.
this. This will be your last level. This is subset of this. This is
Yes.
subset of this. This is subset of this. That's it. This is your Hasse diagram. How to interpret this? Null is related to itself. Null is subset of itself. Set A is subset of itself. Set means every element are subset of itself. That is reflexivity. Now, null set is subset of this set. Null set is subset of A comma B because A is subset of A comma B. Null set is subset of A comma B comma C also. Null set is subset of B. Null set is subset of this. Null set is subset of this. Whatever. Set A is subset of this. Set A is subset of this. Set A is subset of this. Sorry, this. Set A is subset of this. And likewise, means you are going back from Hasse diagram to this also. So I'm sure now there is no confusion now with respect to this. So what I will do now, I will give one Hasse diagram on screen, and Sharvari, you need to answer this now. I'm just drawing one Hasse diagram. Okay. So this question is to everyone, but Sharvari, you will answer me. You will work on this. This is given Hasse diagram. Convert this Hasse diagram into relation R. And tell me what is the cardinality of this relation R. This is a Hasse diagram. So remember, this is a partial order relation. So this relation R is a partial order relation. So I want a cardinality of R. Okay, Sharvari, tell me step by step. 2 is related to whom?
2 is related to 18 and
Pardon?
2 is related to 18.
I'm not able to hear properly. Again, repeat.
Hello, sir.
2 is related to whom?
18.
Madam, this is Hasse diagram. We are going from top to bottom.
Okay,
When I
sorry,
say
sorry, sorry.
A is related to B, it means B. A is here and B is here.
Sorry.
And this is a Hasse diagram. That means what? We avoid self loop in the diagram. But now we want to convert this diagram back to the relation. So now I'm asking step by step.
2 is related to itself.
Okay, 2 is related to 2.
Yes.
Now 3 is related to whom?
Itself.
4 is related to whom?
4 is related to 2.
And
Uh,
check out these edges. No, you are going from top to bottom. A is related to B, where A is this and B is here. A is related to B. So 4 is related to whom?
4 is related to 2.
So 4 is related to 4 and 4 is related to 2. Okay. Next is which we have covered 2, we have covered 3, we have covered 4. So 2 is over, 3 is over, 4 is over. Next is 9. 9 is related to,
9 is related to 9 and 9 is related to 3.
very good. Next is 12.
12 is related to 4 and likewise 12 is related to 2 and 12 is related to 3.
Pardon?
12 is related to 3 and 2.
Again repeat. 12 is related to whom?
2, 2, 2. 4,
Madam, this is 12.
yes.
This relation R is reflexive, antisymmetric, and transitive. When you do have A is related to B and you do have B is related to C, then A is also related to C. This is transitivity. So again, our question is on 12. 12 is related to whom with respect to this reflexivity?
4.
Madam, reflexive means what? Reflexive means what? Element is related to itself.
Yes. Sorry, 12 is related to 12.
Huh.
Then
Now
4.
go with this transitivity as well as antisymmetric. So 12 is you just look at here now. A is related to B. How we interpret this? This is A is related to B. So now I want to know 12 is related to whom? I am asking this now. 12 is related to whom? I want this.
So 4.
Okay. What else?
3
What else?
and 2.
Because of transitivity. 12 is related to 4, 4 is related to 2, therefore 12 is related to 2. So perfectly answered. Now going for the 18th. 18th is related to whom?
18.
Hmm.
9,
Hmm.
3
Hmm.
and 2.
Perfect. Very good. So this is what we discussed just now with respect to Hasse diagram. So we'll stop here at this point of time. But before closing this session, I will pose certain question to work by yourself. Let me give some questions. Wait a minute.
Excuse me, sir.
Yeah, you can mute now. Any
Sir,
doubt?
the portion for IIT.
I already described at the beginning itself. Chapter number 2 entirely we have covered. It will be there. Chapter number 1, just now we have discussed mathematical induction. It will be there. And whatever we will cover in tomorrow's session in rules of inference till this point, this will be there. Predicate calculus we cannot cover. And coming towards this module number 3, we just now seen what is partial order relation, what is poset, what is Hasse diagram. So till Hasse diagram, if time permits tomorrow, if I complete this chain and anti-chain and lattice, then till this point there will be syllabus. So syllabus, definitely your module number 2 will be there entirely. In module number 3, we have covered up till now this. If I cover this tomorrow, this portion, even this will be there for your syllabus for IIT 1. And for the first chapter, mathematical induction will be there and propositional logic will be there, which includes laws of logic that we are discussing along with inference of theory. Predicate logic we have not started, so this will not be there. Quantifier will not be there. Even normal form we completed. This is you already completed in your digital logic design course also, which you call it as a sum of product and product of sum form that way. So this is the portion for your IIT 1. Okay. So we'll stop here. You can post your attendance in the chat.
Sir, in the second chapter is coming full. So in the first and the third, can you just post in the group which are not going to come?
Yeah, tomorrow we are having one more class, no? So I will
Yes.
wait for tomorrow. Let me
Okay.
complete whatever I am able to complete in tomorrow's session. On
Okay.
the basis of that, definitely I will post. But there is no question about module number 2. It is
Yeah, it
definitely
is full.
only about this and this. Okay, I will clearly tell you in module number 3, definitely you will not have anything with respect to this in your IIT 1.
Okay.
So you will have IIT 1 up till this part from module number 3. Partial order relation we have completed. POSET we have completed. POSET is nothing but partial order relation on set. That is what POSET. Hasse diagram just now we have completed. Chain and anti-chain is with respect to Hasse diagram only. That we will complete tomorrow itself. So this much is portion for your module chapter number 3 for your IIT 1. In
Yes, sir.
IIT 1 for chapter number 1 mathematical induction 100% there will be
Okay.
propositional logic 100%, which includes laws of logic and rules of inference that yesterday we discussed.
Okay.
This is your syllabus for IIT.
Okay, sir.
Yeah.
Thank you.
Yeah.